Hello and welcome to another episode of Throttle Stop Garage. In today's episode, we need to get a scan of our brand new steering rack and make sure it's going to work in the new suspension design. Stay tuned. Okay, in response to some of the feedback that I got in the past episode where I reviewed the Revopoint MIRACO scanner, and there it is there, several people have asked me whether or not I could compare it to some other scanner, and truthfully I can, because I also happen to own one of these, or at least work owns one of these and I can get access to it, and that's an Artec LEO. So in today's episode we're going to have a look at scanning the steering rack, and we're going to use these two different pieces of technology. Now, in terms of scanner, they're dramatically different. One of these is pretty heavy and also very expensive. The other one, reasonably lightweight and fairly cost effective. And let's see which one works best for you in the garage. So I'm getting set up to do the scan of the steering rack. Now I have an existing CAD model that I doodled up, and it's a rough representation of what this rack might be, but I was never sure that I got pinion angles and all the other stuff, the lines and things, and I was never sure if I got all that stuff in the right place or so in the correct location. And I desperately need to make sure that all of that is right. So as I go forward, and I'm going to be doing the rest of the modeling for this, like I need to know how long the brackets are going to need to be, not just to clear the rack, but to clear the lines. I need to have, this physical part with the correct orientation. But one of the things that I know about doing complicated parts like this steering rack is it's really going to benefit from a little bit of a scan spray. Now you can buy scanner 3D scanning spray for about $100 a bottle Canadian for an aerosol can. I think it's less obviously for American viewers, but what I'm trying to say is it's not cheap. Now I have found that baby powder and alcohol, just isopropyl alcohol, does work. It's not a perfect solution, but it's pretty good. Last time I just used it in like a spray container, and it was actually reasonably crappy, so it produced sort of blotchy nonsense like this. That actually works. Crazy as it sounds, it's just breaking up the form. But in this case, what I'm going to do is I've got a cheapo minigun, and we're going to give it a shot with the minigun and see how it sprays. I've set the gun up to about 2 bar or 30 odd psi. I've just run some thinner through it to keep it clean. I usually leave my guns with a bit of thinner in them, and we're going to mix up another batch of this stuff. Now I don't need a ton. I'm only going to just coat this. So all I'm going to do is shake a bit of powder. I'm precisely measuring nothing. Again, we know that this is going to go everywhere in our shop. Making the shop nice, smell nice though, I gotta say. So into this I've got, I don't know, just a wee little bit, and we're going to put it in. Some people have suggested, say, a 4-to-1 ratio is about right. I don't know. I'm going to put enough alcohol in there that I think it's a good idea, and we're going to see how that works. So it disperses pretty readily in the alcohol. It's not a real problem here. If I was thinking, I would have grabbed a stir stick for it, but see, that's kind of a thicker slurry than I'd like. So I'm going to thin it out just a bit more to make it a sprayable consistency. I'm going to set the steering rack up now so I can spray it, and I'm going to scan it in the same position that I'm spraying it in. So we'll be back in a second when I've got all that sorted out. I've mounted the rack onto the rafters, and I think we're ready to spray. I'm not worried about getting the spray material into stuff. Again, it's baby powder. Once the alcohol is evaporated, it's gone. And we're going to use a similar technique to the technique that I used for spraying PVA when I'm making composite molds. So it's going to be really light. Just want a really light spritz over it. And when I'm done, I probably just compressed air or a little wipe down with a cloth is going to clean all this mess up, and it shouldn't be a problem. But I've also got it in a good position to scan. Again, when you're scanning, you want to be able to sort of see how you're going to get to that target. This is a round thing, so I'm not too sure how it's all going to work out, but I've got enough features here to pick it off. I'm happy with how it all mounted up. So I'm going to load the slurry right into the cheap spray gun. I don't know if you can see the consistency of this stuff, but it is reminiscent of paint. I've mixed far too much playing with ratios. I don't know. I've never done this before, so we'll see if it works. I've also never used this gun before. How many rules are we going to break? The first thing I know I'm going to do is I'm going to turn down. I usually spray everything with a wide open fluid tip. That's a habit. Oh yeah, that'll spray. Okay, so I want the biggest fan this little gun can give me. I have no idea what that looks like. It'll probably fall apart at some point, but I want it to, instead of going with that fluid needle all the way open, I'm going with the fluid needle almost all the way closed. And we'll just see what the atomizing looks like. Yeah, that's all right. You can already see it more on the lines than anything. Just dust on a coat. Easy peasy. In essence, we want to get the shine off of it. System isn't going to like shine. And we want to make it uniform. I'm not worried about cleaning the grease off the rack. I want the grease on the rack. That's keeping the baby powder out of my brand new steering rack. Now, I don't think baby powder is going to adversely impact my steering rack, but you know, one never knows. Oh, this is miles better than it was before. Make sure I get it coated. Then we'll let it flash. It is alcohol based and it is pretty warm here today in Canada, but I might even take that air pressure down just a bit. Let's go for 1.5 bar here. Might be a bit better. Okay, I'm going to let that flash for a couple of minutes. Once the alcohol's evaporated, we'll come back and we'll get this. We'll probably do 3 or 4 coats and we'll get it all coated up. I think you'd agree that worked out pretty well. Some of the oils and things are leaking out of it now that I've let it sit for a minute and dry off. But again, not worried about that. The things that were black before here are now white, so that's going to scan. The stuff that was shiny is not, like the tube and the lines that were black, and everything else in here is nicely covered. And let's see if we'll get a scan out of this. Just like last time, the Revopoint MIRACO scanner is the scanner we're going to be using for the project. I'm not too sure how I'm going to get this scanned, but this is what I'm going to try. So we're going to give it a shot. First of all, I have to switch it. Oh, I'm in far mode. It's got to be, let's just check the settings here. I'm not using markers. I'm just going feature based. I'm going to go with high, so that's okay there. And I don't care about the color of the object. It's irrelevant. It's picking it up already, so fantastic. Actually, I'm going to flip that screen up just so I can see it as I move around the rack. It kind of likes that. Well, this could be all right. I've also taken the lazy man's approach and gone to my chair. If I can sit, somebody suggested last time that if I put a bungee cord on this thing, life would be a lot better. That person is brilliant. I haven't done it yet because I'm not, but I can sure see the benefits of it. Like, it's not a heavy unit, but you do have to hold it for a long time. So, but you know, if I can get that sort of casting and kind of paint it in, always looking at the green dot, always making sure I'm not too far away from things, making sure the scanner catches up with me, then I think we're going to be okay here, folks. Then with the chair, I can kind of swivel, always letting it catch stuff that it already knows. Right? That's the key to keeping tracking anyway. And if you've got very simple geometries, get out the scanning dots. It's just, it isn't worth the pain. See, even that simple rod, it doesn't like that. Or, oh, I may not catch this up. Okay, so we're going to want to pause it there. So far so good. So I had a scan and it was already showing me that it was out of place. Stop as soon as you see that, when you see it, and it will happen, and then just go back and then just delete that, because it's just going to cause havoc in the rest of your scan. So here I can already see that, you know, I don't have the bottom side of these things, so it's not going to be a good model just yet. So you want to go back, start somewhere where you know it's going to be okay. So it likes this area just fine. Get it back into the right distance, and then hit continue. It'll pick it up, it'll snap it back into place for you, and then I'm just going to try to roll under. Remember, you don't have to hold your breath to do this. So. Oh, see, when it does that kind of stuff, pause. So when you see it shift and rotate, that's telling you that the computer is trying to figure out the geometry, and it's sort of lost its brain just for a sec, which it for sure did there. The Leo is, again, it's not an all-in-one process thing. I do need a separate laptop with software that's actually more expensive than the MIRACO. So do consider this. This is not cheap equipment. This retails for about 40,000 US-ish, somewhere in that range. And the software maintenance alone, what did that cost me? The last time I had to pay it, almost $3,000 US, which is outrageous for a piece of software. But you can't even use this without the software. Sure, you can get a scan. You just can't get any of the processing done. So the MIRACO would come out on top there because it's less expensive than just the software to run this thing. So we're going to scan with the Leo now. We'll see how that goes. And then we're going to take this all, put it in the computer, and we're going to take the powder off this. I really need to clean this up. It does clean up nice and easily, though, for people that are dubious as to whether this is a good idea.
Okay, if you don't like flickering lights, you may want to just speed through this section because I was capturing the texture data with the Leo. So that's just like a photograph of what it looks like. I don't know why I did it. I just didn't want to turn it off. Anyway, you can see that the struggle that I'm having with this thing, given its weight. This is not an easy process to do. So I'm holding it by the bottom or by the handle or by wherever I can wring this thing's neck. I did not think I was going to have as much trouble scanning this object with the Leo as I did. Again, I've used the Leo outside a lot with bigger objects, never had a problem with it losing tracking. I thought this was going to be a simple slam dunk win for the Leo, and yet it lost tracking every bit as often as the MIRACO did. Turns out steering racks aren't easy to scan. Who knew?
Okay, with the scans all done, it's now time to clean the powder off of this thing. It's just baby powder. Once the alcohol is evaporated off, that's all that's here. So this is not going to be hard. It should be able to return right back to its normal state, and it costs me $0 as long as I get the baby powder back in the house before anyone notices it's gone. It's fine. Anyway, and just gonna grab the vacuum and just dust this thing off.
So we're over in Fusion, and this is the basic rack that I designed a little while ago in Fusion. I just took the dimensions of the rack and fiddled around and played with that and made sure I got it pretty close. I've since adjusted this to work with the scans, correcting the little errors. Again, things like the insertion of the pinion into the rack part, those angles are really kind of difficult to work out on your own. Like if you're trying to do this, that's not a simple kind of thing to do. So this isn't always as easy as it looks. And I wanted to make sure that the dimensions were in fact accurate. I'm still a little bit troubled by the ball joint, inner ball joint ends. We'll go over that in a minute. But I did want to show you the end results of those scans. So we'll just flip that around to the front side and then rotate it up a little bit. Let's do it this way. It's just as easy. All right. Okay, so using the MIRACO scan, this is the scan from the MIRACO. So it worked out pretty well. Again, I was not focused or concerned about not getting the lines that were coming out of it. And I've done all the alignment here prior to this again, so I saved you the agony of having to watch me do that. So you can see how well it fits. Again, I just fiddled around with the alignment until I got things into where I thought they were as close as I could possibly get them. It is just the subtlest of skin is the difference, and I could play with it to try to make it perfect, but it would be, well, harder than I think it warrants in terms of effort. But there you can see all the basic pieces are in. The fitment is really good, plus or minus. Man, it sure isn't going to matter for this kind of thing. So that scanner's worked fine. Any of the misalignment here, that's just me being lazy. So we now have the complete system in. So in essence, what can happen here is as I draw the rest of the suspension, I can do most of the work with that scan off, just using this to make the bracket points and make everything else work. And I validated that, and I can say, hey, if I need to check lines, line fitment, and other parts to make sure I've got clearance for things, this little piece on the front here, that kind of stuff, you can see it popping out, then I can fix those things up as needed. So that's hey, it's proven itself quite useful already there. Now we can compare that then to the Leo scan. I'm actually just going to shut off the original mount here, and you can just have a look at that scan. Okay, so the Leo scan's actually pretty good. So it's captured all the lines, right? So all the feed lines and return lines for the power steering assembly are in. The detail's quite good. I did scan it a little differently than I did with the MIRACO, right? So I'm pretty sure I'm not going to show it, but I did end up having to add some balled up chunks of tape to the ends that we could pick them up properly. That's a pretty good trick that I've discovered along the way. And then when I was scanning it, the easiest way to do it is to actually scan it with the scanner slightly inclined to the longitudinal axis of this part, because then it's sort of picking things up in the distance rather than trying to capture them as it goes. We can then compare the two scans to each other. So there are the two scans to each other. They're almost imperceptibly different. Again, wherever you see this sort of brownie color poking through, that's where we've got the MIRACO not registering exactly the same as the Leo. So you can see obviously the lines where we had holes. They're still there. Like they just look like one's growing organically right out of the other. So for all intents and purposes, these two scanners are producing in essence exactly the same result. Like I don't think you could really analytically determine the difference between the two. They're both exactly the same features in pretty much exactly the same way. Like I don't believe there would be a difference in, say, mount point locations. We can just sort of have a look there. That's the Leo's mount point locations. And this is what I got for the MIRACO, so it's just every bit as useful. I did have some holes, again, in the MIRACO. I didn't spend as much time trying to make sure I was getting those as I filled them in. I did the best I could, but it did struggle with that more than the Leo, just to be fair. So yeah, that's the difference that about $40,000 worth of scanner gets you. It's up to you to decide whether or not that is necessary for your application. For most of the things that I'm going to do in the shop, especially given that neither scanner in terms of time, both scans took me about the same amount of time to render. It took me several hours to do the scan with both tools. It didn't seem to matter. I've got a fair bit of experience with this stuff now, and I still can't make it come in like 5 minutes or something. It takes very much longer than that. The final step is measuring up this ball joint, and then I can just add it into the model. So I'm using the wiggle method, which I've used before and advocated in the past. So I just tilt it one side, tilt it to the other, I make a mark, and then I draw in where the center is supposed to be from the intersection of those two lines. I then got my grinder out and just cut a big window into that ball joint.
Okay, so you can see we've moved over to the bench. There's the window. And I'm going to measure this off of these machinist blocks because the way that the tie rod was sitting here on the vise just wasn't very accurate. So we're going to do that again because we have to get this as accurate as possible, just because we don't want error. So I tried this with the light, but it was making it kind of hard to see when I lit it from behind, and I'm hoping I can get you in here close enough to see. But if I just touch it off as closely as I can, then I'm just looking for the sort of reflection of the numbers. Here, I have this on the millimeter scale. Yeah. It's not 21, it's not 20. Yeah, I think we were probably okay over there at 21. 20 is certainly not right. Okay, so the original wiggle method gave me 23. This method, again, it just looked like it was different from the one on the vise, but 21 here, that's as good as I can make the measurement. So I'm happy enough with that. And what you want to do is avoid stacking the error. So in the design phase here, as I'm designing around this steering rack, I need to know quite precisely what the pivot to pivot is. If I do not have this pivot to pivot right, I'm not going to be able, well, I'll probably be able to adjust myself out of that, but remember, the line that the lower and the upper control arm make, this tie rod's sitting on there, so if I get it wrong and I need it to be a little, longer or shorter, I can just shift the rack up and down along that line and fix that potential problem and eliminate the bump steer. That's the objective. But if I start out with 2 or 3 millimeters of error per side, so that's 1/4 of an inch overall, that's going to not, again, you're going to still be able to adjust it out, but why create error right off the start? So I'd like to be able to get the error dialed out and just make this part as accurately as I can. So 21 millimeters, we're going to go with that. Happy with that measurement. We've tried it a bunch of times here. That's the number that keeps coming up. Yeah, that'll work. Okay, let's go and then use a pencil. You're funny. 21. I have my tape measure to give me a false sense of accuracy here. That 21 from the base, there to there. Give me 618 millimeters. So I've seen everything from 610, 615, not seen 618 for the center to center of those pivots, but that is where the center to center of those pivots are, 618 millimeters. All right, so we now have the piece of data that we need, and that's going to be a wrap for this episode. Thanks for staying all the way to the end. I'm quite happy with both technologies, but I just wanted to demonstrate it doesn't really matter in the end which one you happen to have. Comparing like for like, so the inexpensive scanner side of the market isn't a real, well, I guess it's a comparison of the different tools, but comparing the things that are at opposite ends of the spectrum in terms of scanning technology, it haven't demonstrated so far that we haven't come a long way since that Artec LEO was first released. They each have their place in the market. I hope that this has been helpful. Now we know that the steering rack is 618 millimeters from pivot point to pivot point, and that's a critical piece of information that I'm going to need as I finish the suspension design and we move on to creating some hard parts. All right, so that's enough for me for today. Thanks for coming along for the ride. I do appreciate all the views, the likes, the whatever that I get. Love the comment section. Let's keep that going. It helps. You're helping me, right? Let's not kid ourselves here. All the advice and piece of information I get down there have been invaluable. And don't forget, keep your stick on the ice.